Good morning, students. So today we will start with the next concept in a set chapter, that is the subsets. So I'll just take one example and I'll define it, how exactly we can define the subset. Is it clear? So now I'll just take the set, that is the X, and this is of set of all students, set of all the students in a class. Okay, and I'll take one more set, that is the Y. So I'll just take Y is nothing but it is a set of all students in a school. Now, with the help of these two sets, I can define the subset is nothing but a set X is said to be a subset of a Y if every element of a X is also an element of a Y. Is nothing but there will be a students in a class. So for example, I'll just take 10th standard, there will be a 100 students in a school. So I'll just take that is the set X. Then Y is nothing but set of all students in a school. Okay. So this is what a class and this is what a school. In a class there will be 100 students. In a school there will be 600 students. I just took only a X is nothing but set of all students in a class. And this is set of all students in a school. Now I can say that X is subset of Y is nothing but in this Y these 100 students will be there in a school, right? Therefore this X is a subset of Y. Can we say that Y is a subset of X? No. So in the school there will be 8th standard, 7th standard and 1 to 7th standard also. There will be a students, okay? But here we have only 100 students. So if I consider in a school there will be 700 students in a school, and I'll just take only 100 students, these are a 10th standard. Now I can say that this is a subset of this because these 100 students will belongs to this 700. But in this 100 there is a less of 600 students, right? So I can say that X is a subset of Y. How can you define the subset? A set X is said to be a subset of a Y if every element of a set X is also an element of a set Y. Then we can say that X is subset of Y. So in other words, we can write in a notation that is X is a subset of Y. This is what the symbol we can use to denote the subset. Okay, X is subset of Y if whenever I just take small letter x is an element of a x which belongs to X, then this X is also belongs to Y because every element of a X is also an element of a Y, then only we can say that X is subset of Y. Is it clear? So we can say that is X is belongs to Y if A is belongs to X. This implies A is belongs to Y. If any element belongs to X, then that element belongs to Y. Is it clear? So we can say that, or we can read above statement as X is a subset of Y if A is element of a X. This implies A is also an element of a Y. If A is not a subset of this, if this A is not there in a Y, then we can't say that X is not a subset of this Y. Is it clear? And it follows that is every set A is a subset of itself. I just take that is X small letter x is belongs to X, or else every set X is a subset of itself. That is, X is subset of X. If I consider X is a set of 1, 2, 3, then I can say that X is a subset of X means all the elements of X belongs to X only, right? Then I can say that X itself is a subset. Is it clear? So since empty set, so as we know that empty set is nothing but, so a set which does not contain any element, then such a set is called as empty set, and it is denoted by phi. Empty set phi has no elements. We can agree for this. Therefore, we can say that phi is a subset of every set. Is it clear? Will you follow this? So, in a phi, there is no element. Clear? Then, for every set, this phi is a subset. So, for example, I can take, so example, A contains some element, that is A, E, I, O, U. This is a set and it contains ovals of alphabets. Now, the subset of this, I'll just start with null. Null is a subset of this A. Yes, you have to agree for this, because this phi does not contain element. Again, we can say that this phi is a subset of this. Then you should remember that while writing a subset of any set, you should start with a phi. Is it clear? So empty set is a subset for every set. Okay, hope you guys understood this. So here is some few concepts. That is, a set Q of a rational numbers is a subset of a set R of a real number. So we can write that. That is a rational number which is a subset of a real numbers. Hope you guys agree for this. Okay. Again, one more is, if I consider a set A is 1, 3 and a 5, then set B is a X such that X is an odd number less than 6. Okay, odd numbers less than 6 is nothing but 1, 3, 5. Is it clear? So now we can write, that is, A as a element 1, 3, 5. So B, which is in a set builder form, we can write it in a roster form like, which is an odd number less than 6 is nothing but again 1, 3, 5 only. So every element of A is also an element of a B. Then we can say that A is a subset of B, and also we can say that B is also a subset of A. Okay. So next I just take one more example. Set A contains 1, 2, 3, 4, and a set B contains 4, 3, 5. And one more, I'll just take 1. So now, can we say that A is a subset of B? We just check with every element of A whether these elements belongs to this B or not. 1 is there, 2 is there, 3 is there, 4 is there. Hence we can say that A is a subset of B, but B is not a subset of A. Why? And it is not a compulsory that if A is a subset of B, then it is not compulsory that B should be a subset of A. So if this is, both are equal. Now you can say that, you can observe above example that A is a subset of B, B is also a subset of A, then elements are the same. We can say that A is equal to B. Equal set. Equal set means that there will be two sets and both the sets should contain the same elements. Then we can say that those two sets are equal. So here for a subset it is not compulsory that if A is a subset of a B, then B, it is not compulsory that it should be a subset of A. Now check with the element of A. 1, 2, 3, 4. 1, 2, 3, 4 is there. Now if you compare with the B as a subset of A, you have to check with every element of a B, it should be an element of A. Is it clear? 1, 2, 3, 4 is there, but 5 is not there in A, hence this B is not a subset of A. Hope this is clear, subset, and this is important one. Okay. So I'll just take one of few simple example that. So 5, then A contains 1, 3, B contains 1, 5, 9, and C contains 1, 3, 5, 7, 9. Okay, we'll just check with symbols. Okay, insert a symbol that is subset and it is not a subset. Okay, for the following pair of sets. So first one, that is 5 is dash B. Second one, A is dash B. Third one, A is dash C. And the fourth one, B is dash C. You just check with the elements of a set A, B, C as well as a null. So as we know that null is nothing but it is an empty set. There is no elements in this set. And a B as a 1, 5, 9. If 1, 5, 9 is not there in a B, then there will be a null, right? So as I said that null is a subset for every set, therefore null is a subset of a B. Okay, now check with the A. In a A, 1, 3 is there. In a B, 1 is there but 3 is not there. Okay, so in a set A, each and every element should be there in a B, then only A is a subset of a B. So here 1 is there but 3 is not there in a B, therefore this is A is not a subset of B. Okay, next A is a subset of C. 1 is there, 3 is there, but you should not bother about the C elements. So in a we have only 2 elements, 1 and 3. C we have a 1 and 3, but you just forget about the remaining elements. So hence we can say that A is a subset of a C. Okay, but can we say that C is a subset of A? No. 1 is there, 3 is there, but 5, 7, 9 which is not there in A, therefore C is not a subset of A. Clear? Now check with a B. Is it B is a subset of C? 1 is there, 5 is there, 9 is also there. Therefore B is subset of a C. B is a subset of C. Hope you guys understood this subset, and this is a quite important one. Okay. Thank you guys.